So in this video we'll talk about tympanometry. By the word tympanometry, a tympanic membrane, we use the tympanic membrane to find the condition of the middle ear. So this test is fully based on the condition of the tympanic membrane, which helps us to know about the condition of the middle ear cavity. So and this tympanometry is one of the tests of the impedance audiometry. Impedance audiometry is of two types. One is tympanometry and another one is stapedial reflex or acoustic reflex. This is the device of tympanometry. Here we can see one probe over here. This probe has 3 channels inside it, and this is a monitor where we can see graph over here. This machine automatically plots graph. Doctors don't have to ask the patient, and they don't have to plot by themselves. So this is an objective type of test. In contrast to this, we have PTA, that's pure tone audiometry. We have Rene test, in which the doctors, they ask the patient whether the patient can hear the sound or not. So that test is the subjective test, but this one is objective test. And this test is a measure of the condition of the middle ear with intact tympanic membrane. So to do this test, the tympanic membrane must be intact. If there is perforation of the tympanic membrane, we simply cannot do this test. We cannot perform this test. So first we need to seal the if the perforation has occurred, then we can try many methods to seal the tympanic membrane, and after that we can perform this test. So this test can be done only in cases of intact tympanic membrane, and this test measures the impedance. Impedance means resistance to the flow of sound energy through the middle ear on pressure changes in the external auditory canal. So the thing is that the probe of the tympanometry, that probe has 3 channels. So each has its own function, and one of the channels of the probe changes the pressure of the external auditory canal. So it keeps on changing the pressure. And why we need to change the pressure? Because first we know the path. We all know that the sound from the external source enters into our ear through the external auditory canal, that is EAC, and it enters into the middle ear cavity. Before entering into the middle ear cavity, it has to pass through the tympanic membrane. So tympanic membrane acts as a wall. So it offers some resistance, so the whole of the sound cannot enter into the middle ear. Some of them enters and some of them gets reflected back, and this how much sound gets reflected, how much can enter, that depends on the tympanic membrane condition. So when the tympanic membrane is rigid, as in cases of tympanic sclerosis, or it is it's like when it is fixed, as in cases of fixation of ossicular chain fixation, like in cases of otosclerosis, when the tympanic membrane becomes less mobile, then at that condition more of the sound gets reflected back into the ESC. And pressure, why we change the pressure? First thing is that by changing the pressure, we try to find that pressure at which the maximum sound gets entered into the middle ear, and that happens only when the tympanic becomes more flexible, or in other way what you can say is that when the tympanic membrane becomes more mobile, then more sound energy gets more sound can enter into the middle ear. And by changing the pressure, we can find the pressure at which that thing happens, means that uh, uh, by changing the pressure at which the tympanic membrane becomes more mobile, the more sound can enter into the middle ear. uh, and that is the main thing. We keep on changing the pressure. We have to find the pressure of the middle ear, because we are trying to figure out the condition of the middle ear. So uh, we will talk about this all thing in the coming slide. So in this slide we just what we knew is that this test is done to measure the condition of the middle ear with intact tympanic membrane, and this measures the resistance to the flow of sound energy through the middle ear on pressure changes in the external auditory canal. So by changing the pressure also we can change the state of the tympanic membrane. So in certain pressure the tympanic membrane becomes more mobile, and in certain pressure the tympanic membrane becomes less mobile, and we'll talk about this in the coming slide. And as I already said, it is an objective test, and it is one of the type of the impedance audiometry. So we can see here this is a tympanometry probe, and it has three channels. Each of them has its own function. See, this channel we are seeing is this upper one. This channel is used to change the pressure in the EAC. So it has got a function to change the pressure of the EAC. And this one, this channel, it has to generate, it generates the sound, usually of frequency 220 hertz or 226 hertz. And the third one, this third channel, this channel records the sound that is being reflected by the tympanic membrane. So if the returning or reflecting sound is more, we can suspect that the tympanic membrane is less mobile, and we can find out the different causes of that. And when the sound returning back is less, then we know that in this we can suspect that the tympanic membrane is more mobile in certain cases. So we will discuss about the cases in the coming slide. See the channel that changes the pressure of EAC. There is a certain limitation. It changes the pressure from plus 200 to minus 400 mm of water, and the pressure at which means the when the pressure of the external auditory canal and the pressure in the middle ear becomes equal, at that point maximum mobility of tympanic membrane occurs. At that point and at that condition, more of the sound energy enters into the middle ear. In tympanometry, we measure two factors. First one is compliance, second one is middle ear pressure. And compliance, it is just the easy of mobility of tympanic membrane. Means when the tympanic membrane is mobile, we can say that it has got more compliance. And the resistance and compliance are just opposite. Means when the resistance to the sound energy is less, means the compliance is more. And any ossicular discontinuity, tympanic membrane mobility increases. uh, the ossicular chain that has the fixed that keeps the tympanic membrane intact. When there is occurs discontinuity in this ossicular chain, then TM becomes more mobile, more free, so its mobility increases. And in cases of ossicular fixation or fluid collection in the middle ear, that fluid opposes the movement of tympanic membrane. So the compliance is decreased. Means when the mobility of tympanic membrane decreases, we can say compliance has decreased. And middle air pressure, we can measure the middle air pressure also, through the probe. One of the channels of the probe helps to change the pressure of the EAC. So we just keep on changing the pressure because we have to find the pressure of the middle ear. And how can we find the pressure of the middle ear? We can find by we just keep on changing the pressure of the EAC, and at the point where at the point when the pressure when the tympanic membrane moves maximum, means the movement of tympanic membrane is more. At that point we can measure that point pressure, and we can say that pressure is the pressure of the middle ear, because TM tympanic membrane movement is maximum only when there occurs resonance. And when that maximum resonance occurs, when that occurs, it occurs when the middle ear pressure and external auditory canal pressure becomes equal. At that point, at the pressure of that point, only TM movement occurs more. So when we find that TM is moving more, then we can note the pressure, and we can conclude that the middle ear pressure is this much. So for example, we found that TM movement occurs maximum when the pressure of ES is minus 200. This indicates that the middle ear pressure is also minus 200 mm of water. What is the significance of middle ear pressure? We all know that the pressure of the middle ear is regulated by Eustachian tube, and this pressure of the middle ear in adult, it lies in this range minus 52 plus 50 mm of water, and in children it is within this range minus 152 plus 50 mm of water. Any deviation in this pressure means, suppose if the pressure is negative beyond this range, if it is more negative than this range, then it signifies that Eustachian tube blockage has occurred. So I put the two cases here. In first case, the compliance has decreased, also the middle ear pressure is more negative than the normal range. So here compliance has also decreased, means the tympanic membrane movement has decreased, and Eustachian tube blockage has also occurred because the middle ear pressure is also negative. And this occurs in the cases like serous otitis media. First, Eustachian tube blockage occurs, which leads to fluid collection in the middle ear, which opposes the movement of tympanic membrane and leads to the reduced compliance, decrease in the compliance. And in second case, the compliance has reduced, but the pressure is normal, means the Eustachian tube patency is normal, only the tympanic membrane movement has decreased. And this occurs in cases like ossicular chain fixation, like in osteosclerosis, where the TM movement decrease but the pressure is normal because the Eustachian tube patency is normal. So here we have a graph, and in this graph we can see 1, 2, 3, 4, 5 types of this 5 types of graph. This type is a normal type. This type is a normal type. So first look, this x-axis here. This x-axis denotes the air pressure, and y-axis denotes the compliance. And we take this 1 unit as a normal range for the compliance. See, yeah, normal range for compliance in y-axis. We take 0 as a normal range for air pressure, the EAC. So this type is normal type. So here we can see in the normal range of pressure, compliance is maximum, or compliance is in the normal range at the normal range of pressure. At 0 mm pressure, compliance is in the normal range. So this type is normal type. And type C, what we see is that Compliance is in the normal range. This pointed in denotes the compliance maximum compliance, and it lies in the normal range. But the pressure has decreased. See, the pressure has become more negative. See, in the normal curve, what we can see is that in the range of the pressure, compliance is in the normal range. When we move in this direction, right direction, or either in the right or in the left direction, compliance has decreased. So compliance is in the normal range only in the normal pressure. In type C, pressure has decreased. It is more negative than normal range, but the compliance is normal. And type AS, pressure is at the normal range, but the compliance has reduced. See, compliance has reduced. And in type AD, pressure is in the normal range, but the compliance has increased to the maximum. And in type B, see this graph, this is more likely a flat curve. You know, both the compliance and pressure is not in the normal range. Both has changed, both has decreased. So see, type is the normal type, and type AS, type AS, compliance has decreased, but the pressure is normal. Means extension tube condition is normal, but the TM mobility has decreased. So this occurs in cases of stiffness. That's why it is denoted by suffix S. S means stiffness. S means stiffness. So it occurs in cases like otosclerosis when the ossicular chain is fixed. That's why the mobility of tympanic membrane is also decreased. Is also decreased. So compliance has decreased. Movement decrease means compliance decrease. And in C type, type C, first look at this AD type. D means discontinuity. Discontinuity of the ossicular chain means the tympanic membrane is free now, is more free, so it can move more. So compliance has increased more, but the stationary condition is normal, so pressure is in the normal range. And in type C, compliance is in the normal range, means TM condition is normal, but the pressure has decreased more in the negative direction, means stationary blockage has occurred. And it is this stationary blockage can lead to fluid collection in the middle ear, which leads to decrease in compliance of the middle ear. But in this condition, the compliance is in the normal range or slightly decreased, because stationary blockage is for short duration only. So in short duration, more fluid cannot get collected, so compliance is not affected so much. But in type B, where stationary blockage occurs for long time, so more fluid can get collected in the middle ear, which opposes the TM movement, so compliance decrease and pressure also decrease because blockage of stationary has occurred. And this is a normal graph. This is the individual graph. I've already talked about the graph, and I made a table which will be easier to look. So in type A, everything is normal, and type AS, AS means stiffness, like in case of otosclerosis or any ossicular fixation. Also in tumors of the middle ear, like glomus dubulaire. So fixation has occurred, but the stationary is normal. So when the stationary is normal, middle ear pressure is also normal. And why compliance has decreased? Because due to the fixation of ossicular chain, TM fixation also occurs. Or in case of tympanic sclerosis, TM becomes rigid, so its mobility decreases. Or in other way, its compliance decreases. And AD type, D means discontinuity, the discontinuity of the ossicular chain, or when the TM is thin or loose. Also in case of post-stapedectomy, where the step piece has been taken out, ossicular discontinuity occurs, and due to this, tympanic membrane is more free, it moves more, means it has more compliance. So compliance increased, but the pressure is normal because the suction tube is normal. And C, closure occurs but for short duration. That's why compliance is normal, because TM mobility is affected less, because fluid cannot get collected in such amount, in enough amount. So the mobility is not affected so much, but the pressure is negative because extensive blockage has occurred. And type B, T blockage occurs for long time, like in case of serious otitis media and adhesive otitis media. Blockage occurs for long time, so fluid gets collected more and more in the middle layer, so compliance is affected, and it has a dome-shaped curve. And when the fluid fills whole of the middle layer, so uh, there occurs no any movement of tympanic membrane, and at that time curve becomes flat, this flat, straight flat, because no compliance is there. See, here I mentioned, when the secretion of fluid fill the cavity completely, then there was no movement of tympanic membrane, so the flat curve occurs. This is our section of tympanometry.